Lesson 11-7, Volume of Pyramids and Cones. By the end of today's lesson, we will be able to find volumes of pyramids and cones. Theorem 12.9, the volume of a pyramid, states that the volume V of a pyramid is V equals 1/3 base area times the height of the pyramid. And then again, where B is the area of the base and H is the height. So right here we have a right. This is perhaps a square pyramid. It's right because it's standing at a 90-degree angle. But you can also have an oblique pyramid, meaning it's slanted. So this formula still applies as long as you're referring to the height that's 90 degrees. So if you look at example 1 here, it wants you to find a volume. And we will have to use the height of 10, even though it's oblique. As long as the height is 90 degrees from the base, then that's okay. Now, for the base here, we have a regular hexagon. So we have to use the formula of finding the area of a regular polygon. So that would be half times the bottom times the perimeter of the base. So I'm going to use B here because that's to represent the base area. So the bottom here, we know that it forms isosceles triangles here, and taking 360 degrees and dividing by 6 will give me 60 degrees. And since this is the angle bisector, then this is a 30 degree. And this will be 60 degrees. And half of 4 is 2. So I know my apothem has to be 2 square root of 3. I'm going to write it here. And since one side of the regular hexagon, is 4, and then 4 times 6 would give me 24. So this would be my base area. I can simplify it to get 24 square roots of 3. And now I'm ready to calculate my volume. Volume equals 1/3 times base area times the height of 10. So by using your calculator, or let's first simplify. How about that? We will get 80 square roots of 3. And you might be asked to write it in decimal form, so 138.56 cubic inches. Okay, let's practice this one more time. Here again, let's draw this triangle in here, and then you have an angle bisector. 90 degree. This is 30, 60, because again it's still a regular hexagon. Half of 9 is 4.5. So your apothem is 4.5 square root of 3. So the base area should be represented as half times 4.5 square root of 3 times the perimeter, 9 times 6, which is 54. And then we can go ahead and find the volume. Remember, volume is 1/3 times base times area. So base is half times 4.5 square root of 3 times 54, and then times the height of 15. And you simplify this. So this would be 607.5 square root of 3. If you were to leave your answer in simplest radical form, but if you were to round this, it would be 1052.22 cubic centimeters. Theorem 12.10. The volume of a cone. The volume V of a cone is represented as V equals 1/3 the base area times the height, and the base area is just pi r squared. So again, B is the area of the base, and it's always a circle. H is the height, R is the radius of the base. Now example 2, find the volume of the cone. So this is a right cone, meaning it's standing at a 90-degree angle. So here we go. Volume equals 1/3 times the base area, which is pi, times, now we're given the radius, 9.5, so 9.5 squared, times the height of 16.8. And this would give you about 1587.76 cubic millimeters. Now let's look at another right cone. You're given a radius of 6, a slant height of 10. So this is a Pythagorean triple, 6, 8, 10. So the volume will be equal to 1/3 pi r squared, which is just 6 squared, so 36, times the height of 8. That's 96 pi, so that's about 301.59 cubic feet. And now we have an oblique cone, meaning it's slanted, but we're given the height, so that's okay. I'm going to go ahead and use the same formula. Volume equals 1/3 pi times r squared, so 4.5 squared, times the height of 12. And that gives you about 254.47 cubic feet. Example 3. Find the volume of the right cone. Now, we don't know the radius, but we know the height. So we can use trigonometry again to find the radius. So let's use tan 62 degrees equals opposite over adjacent, so that's 12 over r. And after you use your calculator to find out what r is, it should be 6.38. Then I can find the volume. Pi r squared times the height of 12. So this would be equal about 511.6 cubic meters. Okay, for the next one, we need to find out what the height is. I'm going to use tan again. Tan 32 degrees equals opposite over adjacent. So this would be 7 over h. And h should be about 11.20. And the volume be 1/3 times pi, radius of 7, so 7 squared, times 11.20 as your height. So this should be about 574.70 cubic yards. Example 4. Find the volume of the composite solid shown. Composite solid just means that you have different kinds of solids that are attached to each other. Anyway, part A, we have a cylinder and a cone. So the volume would just be pi r squared h plus 1/3 pi r squared h. So for the cylinder, the radius is 3, so that would be 9. The height is 7. And for the cone, the radius is also 3. So 3 squared makes 9, then the height is 3. Then we can simplify this. We have 63 pi plus 9 pi, and this is 72 pi. So you can either leave it in terms of pi, or if you're asked to leave it as decimal form, so you just round it, 226.19 cubic centimeters. And for part B, you need to subtract the volume of the cone because that's hollow inside. So again, first find the volume of the entire cube, which is just 5.1 cubed, and then minus the volume of the cone, which is 1/3 pi, and r would be half of 5.1, which is 2.55 squared, and then times the height. And by using your calculator, you should get 132.651 minus 34.73, and this should be about 97.92 cubic meters.